my colleague and co-author Jeremy Holden is not here, so we actually just sort of smushed both talks together and we're going to be running straight through, and then hopefully there'll be some time for questions at the end. Want to acknowledge our funding sources, and especially draw attention to Ontario Ministry of Natural Resources and Forestry. This is the first year that they joined the bottom trawl survey, which was typically the survey we used to report on these FCOs. It was also the first year we, USGS, joined the hydroacoustic survey. So we're excited to be really presenting the first year of all three boats doing whole lake crayfish surveys. A couple high-level sort of insights I'll have you looking out for. One is we're trying to talk about more comparable CPUEs. We're talking about the impact of trawl corrections on the time series, how it maybe changes what we're thinking about certain pelagic crayfish out there, and expanding our focus, thinking now whole lake. So just kind of insights there, right? Does the U.S. equal Canada? Most of our pelagic crayfish surveys have been U.S. based for 40 years. Now they're more broadly expanded. That bottom trawl survey expansion here at the top shows the historic black points, the transect-based design, anywhere from 100 to 110 samples. In 2016, we did 188, moved it throughout the entire lake, did a bunch on the Canadian shore as well. Our LOC Crayfish Community Objective 2.3 mentions crayfish diversity, so we'll speak to that, but it also talks about alewife, cisco, smelt, emerald shiners, and three-spine sticklebacks. Diversity is low. For those of you who don't know, it's an alewife lake. And you might look at a different survey and get a slightly different number, but that number throughout time has been alewife, and it's been really increasingly more an alewife system. If we just use a sort of a Shannon diversity index, it's about as low as you can get. The only way to get lower is to have just one species. There were some little blips of three-spine sticklebacks back in the day, but really the proportion of alewife and smelt is what's driving that indice. I'm going to start with all the other species and talk about rainbow smelt. The one thing you'll notice is we're not reporting the rest of the time series. Traditionally, here I was showing 78 to 2016. Here we're just talking about 1997 to present, and that has to do with those trawl corrections that we'll get into. But for rainbow smelt, we see both the U.S. number there, calculated as before, as well as the Canadian number, calculated basically just for the area in Canada, and the trawls there were similar. They both were up. The Canada one was a little higher. We did have fewer trawls over there, attributing to the variance difference. And if you think about it, the lake's basically 50-50. So if you want to take a whole lake average, it's probably right in between those two. We are talking about a catch per unit effort in kilograms per hectare now, trying to report the same densities that are reported in the other lakes to help that comparability, so we can help learn, transfer knowledge between systems. Emerald shiners, three-spine sticklebacks, and cisco. It's not a great, bottom trawl's not a great survey for those, but they're also not showing up. When they do show up, we did catch more, as I mentioned, and sticklebacks were higher, but those other species really aren't well sampled in this survey. We have seen a resurgence in cisco in the more recent times. We'll talk a little bit about that in the acoustics as well. So this trawl correction that I'm talking about happened in '97, where mussels forced us to move from a historic Yankee trawl, same trawl that's used in Michigan and Superior, same design, fishes very hard on bottom, excellent for benthic fish, excellent for catching mussels. So they moved to a 3-in-1 trawl here depicted, fish much lighter on the bottom, but it was also much higher, right? So at the time, they were very diligent about doing comparison towing and understanding by how much more were we going to have, how are we going to correct and start linking these time series together. At the time, it was, well, let's link the new series back to the old series. and Bob Gorman and Gene Adams worked it out. The rule they decided at that time was reduce a catch with this new trawl if it was beyond 92 meters by 72%. That 92 meters is an important piece to think about, because what's happened is in that springtime trawl, the alewife distribution has been shifting. Initially, when they came up with these numbers, late 90s, mid 90s, maybe 20, 30% of the population was beyond 92 meters. Now, there's years when 95% of our catches are getting corrected and reduced by 72%. So it's that sort of that trend in getting deeper. You think about what that's going to be doing as we continue to correct more and more and more, what that's going to sort of do to the time series as we see it. Here, this is the adult alewife as you would usually have seen it in previous past reports. This is a point instead of a bar graph, and it's the mean number caught per 10-meter trawl. That is a significant decline through that time period. If you take that correction out, we see two things. One, there's way more alewife out there, but more or less we get rid of that trend as well, right? So we were forcing that trend in because of the depth shift and the correction. When we just look at the same kind of analysis, a stratified area weighted analysis for estimating the actual mean number per 10 minutes, we don't see that survey. We don't see that same result. Now, it doesn't change, this doesn't change the interpretation that you've heard about in the stocking cut and the change in year class. We still had two incredibly low, the lowest ever, and another low back-to-back year class that changed the age structure and is now influencing the adult abundance. So if we look at the H2 alewife abundance now, reporting that just in the kilograms per hectare perspective, we can look at it that way and say, okay, wow, we're quite a bit higher than the other lakes. And that number out here that we've seen in the US, if we actually overlay the Canadian number, we see there's some impact of where we're looking for these fish. Proportionally, a few more on the North Shore could actually make quite a difference, because it's 50-50, maybe there's double the alewife density on that North Shore in the springtime. That could be really influencing our understanding. Similarly, in years like this where alewife density is low and then miraculously jumps up, our population models show that's not right. We missed them for some reason. Could have been on the North Shore. Likely numbers that are extraordinarily high and then drop back down from one year to another. These are the things we're learning about the index, where you just can't use the index as your total understanding because it's potentially biased by where that survey was collected. So our age 1 indice, we have our Canadian numbers here in red and our US numbers beneath them. We did see a year class come through. We measure year class and age 1 abundance, and so that would be the 2015. The catches of 2016 of age 1s are from that 2015 year class, and these are those 2 year classes that prompted the management action. So take-home messages from the trawls. Diversity remains low, you know that. And in 2016, adult alewife were down, but as expected. But we're not ready to make that whole lake estimate and say we're sure of that, because we only got, I'm going to say, 46 trawls, I think, relative to 142 in the US side, 46 in Canada. We were excited to get them. They gave us some insight, but we really need to even out that sampling distribution to better estimate whole lake biomass for density of alewife. Age 1 alewife was about average, certainly up relative to what we've seen. So as we talked to sort of the angling groups that had been, if you were there in Andy's talk yesterday, really a big portion of what was going out and being, used to explain the need for the reduction was that change in age structure. We showed them, yeah, we do believe we see more age 1 fish back in the population. Smelt were up slightly and Cisco were up. Where are we headed? We certainly want to maintain this collaborative approach. We feel like we're learning a lot more, not just because OM&RF has joined the trawling program, but because we're learning more from Lake Michigan, Lake Huron, Lake Superior, inland systems, trying to take a more landscape approach to thinking about prey-fish dynamics in these systems. We're going to go more whole lake. We're going to, as long as the funding holds out and the people and the resources are there, we're trying to take that whole lake approach and figure out what's driving some of those spatial patterns that we see in the spring or late winter. And then working towards a population model that's informed by all the sources that we have. Similar to the other lakes, maybe just focused very, initially in a simplistic alewife catch at age model. But we'd like to help, have that model so we can assess the relative strength of the different drivers, be they physical or some of the food web drivers that you just heard Tim talked about. So in 2017, this is our plan. You remember the previous graph of what we had been historically doing. This is our plan for 2017 for trawling, trying to get out into those areas. But we are limited by some things. Things like the entire North Shore is all rocks. Trawls don't like rocks. So there's places we can't go. There's places we can't go because the ports are few and far between. But we've got incredible support from our vessel staff and the funding agencies to put this up, try to get out at this spatial scale. Unlikely we'll be able to keep this up, but once we learn from this, we can then dictate and focus our efforts in those areas where where variance is highest. But we can't give up the old survey without the sort of comparative information. We're also going to be looking at things like a tow time study. Really what we found is if we're shoveling alewife, if we tow for just 5 minutes less, it only seems like, we'll save maybe 50 minutes in a day. But, dealing with half of a giant bag, even if it's just half a giant bag, really cuts down our time, allows us to get those few more tows, allows us to get to the next transect. So we're really trying to sort of hit that sweet spot of information and efficiency. So that's the end of the trawls, and now we're going to move right into the hydroacoustic assessment. Again, acknowledging my co-authors, very similar funding sources as before. And really, if you've been here before, you've maybe seen figures of acoustics versus trawls, and what do they say? And, Jeremy had some great pictures. He took them out of like a boxing match, which one is right? Neither are right, they're both wrong, but they complement each other. We can learn from both of them. What can acoustics do? Acoustics don't care about the rocks. They can go anywhere they want. The other thing, if we think about how much area is actually sampled, our historic distributions covered about 70 kilometers. We bumped that up, we almost doubled it for trawling. Relative to acoustics, the standard survey alone does 350 kilometers in Lake Ontario. There's an additional about double that amount of learning transects where we're specifically looking for different aggregations of fish and trying to understand how variability in acoustic density estimates near shore might influence that total number or density of prey fish. As before, you saw that bar chart, right? Kind of only have 2 species. Show you think, little teaser. Kind of think we only have 2 species, and they're alewife and smelt, and it's fairly simple species partitioning. If you look at how some of the stuff that the folks have to do in Lake Michigan, partitioning out what's a bloater and what's a Cisco. Here, it's up and it's warm, it's above a 10-degree sea line, it's an alewife, it's below, it's a smelt. And that allows us to put together a time series for alewife that in 2016, the value came up from 2015 and was about near that 12-year average. So acoustics does see a little bit of a different proportion of the population because it is done in July. And what's also important is right now how it's thresholded, what they consider to be alewife things. It produces a number and a biomass density of 8 kilograms per hectare that's far different, far lower than what the bottom trawl is. And this was always sort of meant to, this was viewed as a problem with the acoustics, but really it has a lot to do with the assumptions and what we don't know about target strengths and things like that. By working collaboratively across the lakes, we're starting to look and say, oh, well, if we use more of a Michigan approach, those numbers all of a sudden get a lot closer together. And so this isn't the final take on that. We're continuing to learn, but it does complement. And what's kind of interesting too is this trend hasn't been declining for years. It's kind of been bouncing around and not declining. Seems a lot now more realistic, given that the bottom trawl is doing something very similar. We got rid of that correction bias that we had in there. Rainbow smelt, there's still not very many smelt. It doesn't matter what you use. But the density estimates for those are much closer. I should mention one of the big reasons why the acoustic and bottom trawl differ by so much is what proportion of the alewife are up in the uncountable region of the lake at night. And so that's we'd say the first 6 meters, Mike, 0 to 6 meters, where acoustics really aren't able. You have that sort of that dead zone at the top as well. The cone's not very big, and the transducer's a couple meters underwater as well. So if you get what could be twice as many or the same number of fish in the 0 to 6 meters that you can't count as in the 6 to 30 meters that you do count, it has a pretty big effect on your acoustic density. What was different, I mentioned about 2016, was the CAHO joined the survey, USGS we got involved, and the way we figured out was probably the best way to use that additional effort. The Seth Green, the state boat, and the OMNRF boat had been doing the survey pretty well, but they weren't able to get a lot of midwater trawling done or apportionment, figuring out what those blips were. And so that's what we took on in the spring, in the eastern 1/3 of the lake. We were sort of targeting this assessment on Cisco. And that was because they had been seeing a lot of big targets deep that they didn't think they could attribute to smelt. So we took this survey approach and we went out there, and this is the acoustic echogram on the first transect as we were getting ready and coming into shore. And those of you who are familiar with this is, if you're in Lake Superior, that's what Dan Ewell would call your Cisco layer. That is right up next to shore, starts somewhere at 60 to 70 meters, right there at the thermocline, incredibly thick, incredibly dense. The catch from that in our first trawl was pretty surprising. It was a lot of big Cisco. There was counting 1, 2 alewife in that midwater trawl catch. A bunch of smelt, but mostly Cisco, a lot of Cisco of 1 or 2 size classes, as well as a few other big ones. Here's just sort of looking at that Cisco size distribution. In about 30 to 40 trawls, we caught 360 Cisco, which is more than the bottom trawl survey has caught in 42 years of existence. So it's a gear that works, right? We didn't stumble upon this. This was, through the advice of folks like Dave Warner, Dan Ewell, Mark Eagner. Those folks have really helped us through this process of figuring out how we might sample this fish species out there that nothing else was getting. It's prevalent in the east. Our samples there show in the dark where it was present and where it was absent. And then what was really kind of also interesting is we had a big northeast blow. The lake flip, we went back out and repeated it, and those fish were absent in all those spots as well. So we happened to just pick that one week where we caught the Cisco in that one region. But now, if you'll allow a little bit of hand waving, how many might it actually represent? Well, for the midwater trawls alone, the density estimates were about 36 per hectare. From the acoustics in those really thick layers, average of about 51. If you use that thick layer and actually extend it out across the lake where we know there's places where there were and weren't Cisco, about 25 fish per hectare. A little bit of back of the envelope calculations. All right, let's assume that's a tenth of the lake, and you had 25 fish per hectare. We assume the rest of the lake had 0 fish per hectare. Conservative, not true based on what we see in the acoustics, but we didn't have any trawls out there. That's 2.5 fish per hectare, or 4.7 million adult Cisco in the system. That equates to, conservatively, half a kilogram per hectare. For comparison, Lake Superior, 5.5 kilograms per hectare in, I want to say 2011 or so, if Daniel's still here. That number's a lot lower these days. So, not saying Cisco densities are equaling what we see in some of these other systems, but they're certainly not as low as what our targeted bottom trawl surveys or maybe some of our other surveys might have suggested. So with that, it looks like I have maybe 3 minutes left. Is that right for questions? I'll take it.